Alright, hey everyone, we're going to talk about the exponential function and also the derivative of it. So this is your basic definition of the derivative of e to the u just being some variable, some like x, theta, t, whatever it may be, right? For example, if we use x, it'd be du over dx, but when we take the derivative, it's just going to be e to the u, so that same, whatever we started with, e to, say, x, will equal e to the x, and then times the derivative of x with respect to x. But u can be anything, u could be any variable, and any coefficient of the variable as well, like 3x, 2x, 2t, whatever it may be. And then times the derivative of that power that the e is in. So let's go ahead and work out a problem or two. So number one says y is equal to e to the negative 5x. All right. Now the derivative of that, we have y is equal to e to the negative 5x. Now we got to remember that the derivative is just the same thing, e to the negative 5x, and then times the derivative of our u. Now what's our u? Our u is this negative 5x. So the derivative of negative 5x would just be a negative 5, right? So times a negative 5. Now all we got to do is just combine like terms, or not combine like terms, but multiply. So negative 5 times e to the negative 5x, that would give me a negative 5e to the negative 5x. And that would be it. So this is a pretty easy one, right? But that's number one. Now let's look at number two. Number two is saying y is equal to e theta sine theta plus cosine theta. And this is multiplied by the e theta, right? Now, number two, sine theta plus cosine theta. Oh man, wrote a 3 instead. Okay, cosine theta. It's a terrible looking O, but alright, now we got to notice something here. This e theta is being multiplied by sine theta plus cosine theta. Okay, so we treat this as kind of like 1, but we notice there's a product of what we have variables of. So that gives us a hint that we got to do what? The product rule from Cal 1, right? Now, the product rule just means that we're going to take the derivative of one of the variables, or term, so e theta. The derivative of e theta, remember, derivative, it's e to the u times du over dx. So e theta, the derivative of u, which is theta, that'd just be 1. So it just end up being e theta, because 1 times e theta would be e theta. Now, so the product rule, if you remember, it's the derivative of one of them, and then you leave the other alone. So we're going to leave the sine theta plus cosine theta alone. And then we say plus, and we leave that other variable alone, in this case the e theta, I'm going to leave that alone now. And now we're going to take the derivative inside of all this, inside of the sine theta plus cosine theta. So what's the derivative of sine? It's cosine. And the derivative of cosine is negative sine. So we end up having, I'd say plus, and then basically that negative sine theta. Oops. So, alright, now if we simplify this a little bit, we have e theta times the sine theta plus cosine theta, and then plus e theta, and then this side right here, right? Now the only thing to do now is just distribute. Let's go ahead and distribute these e thetas, and we get e theta sine theta plus e theta cosine theta plus e theta cosine theta, and then minus e theta sine theta, right? After we distribute this e theta to this one, and then also this e theta to these. And let's look at it. Do we have any like terms? You always want to try to simplify on these types of problems. And I notice here that I have a e theta sine theta and also a minus e theta sine theta. So what does that mean? They're gonna go away. All right. So then we have this e theta cosine theta plus another e theta cosine theta. That's going to give us two of those. So we're going to end up having 2 e theta cosine theta. And that's it. That's our answer for number 2. Alright, now we're going to go ahead and move on to the integrals now. Alright, now integrals, the rule is this. Okay, the integral of e to the u du is equal to e to the u plus c. So basically, you're just going to integrate the e to the u, and you're going to get e to the u again. Alright, now, the thing is that whatever your u is, you're going to have kind of have an integration right here of the u, but we'll go ahead and work some problems when that case happens, but right now we're not really into that. We're just going to do some more basic ones, I guess, and a little more difficult ones, but they're still pretty basic, so don't worry. E to the u plus c, so very straightforward, just like the derivative of the e to the u, but we'll go ahead and work out a problem, okay? So we'll take the integral of from natural log of 2 to natural log of 3 of e to the x dx. So if we integrate e to the x dx, what is it going to be? Remember, e to the u du, it's just e to the u plus c. So this is just going to be e to the x, but instead of c, because we have limits here, right? From natural log of 2 to natural log of 3. So we don't have the plus c, but we have this. And so we got to plug in to this bad boy right here to see what we get. Now, this is going to give us e to the natural log of 3, and then minus e to the natural log of 2. Now, what we got to remember is e, when we have e raised to a natural log of something, the e and the ln are going to cancel, and the 3 will come down. Same thing right here, e and ln they'll cancel, and then the 2 will come down. So we end up getting, this will go away, right? This will go away, and this drops down, this drops down. So we end up having 3 minus 2, and that is equal to 1. And that's the answer for that one. Okay, now we're going to do another problem. Alright, now the integral, you're probably, okay, this is the integral. You're probably thinking, what the hell, what is this? This looks crazy, man. Some kind of Greek, I don't know what this is, but it's really not bad. There's an easy substitution of this problem, and once you do the substitution, it's just easy integration, okay? So let's think of this secant, right? We see this secant here, and remember, we're dealing with integrals from e to the u, so it's a little hint there that we should let this equal u, and what's the derivative of secant? Secant tangent, right? So we'll go ahead and let u equal secant pi t. You know what? I should probably write it over here. More room. But we'll let u equal secant pi of t du will equal secant pi of t tangent pi of t, and then the derivative, remember we got a chain rule in here, so we got derivative pi t, that's just going to be pi. So times pi. And now we notice right here in the beginning of the problem, we don't have just a pi anywhere, right? Like just by itself. So that means we got to take this pi and move it to the other side so we can move it outside of the integral. Since this is a constant, pi is a constant. So we got to move this out of here. Now how are we going to do that? We could multiply this du, this equation right here, by 1 over pi. So what happens there is this gets distributed right to this side. So the pi, 1 over pi, and then times the pi's are going to go away. And then you also distribute it to this side. So you end up having that du over pi is equal to secant pi t tangent pi t. And then, of course, the dt. Forgot the dt over here, but should be times pi dt. But anyways, when we divide it by pi, we have the pi over there, and now we're ready to go. Because this pi is outside, we could rewrite the integral with the 1 over pi, right? And then now we have the e, and we let u equal secant pi of t, so this is going to be e to the u now, and du is going to equal all this, so we can put e to the u du, okay? So e to the u du, and now we're ready to integrate. So the integral of e to the u, remember, is just e to u plus c, but remember we have that 1 over pi on the outside, so we're going to have 1 over pi e to the u plus c. And then now we just plug in our u, which we let equal, remember, secant pi t. So we're just going to plug that in where we had our u previously. And that's it. We're done. Not bad at all, right? So that's pretty much it with the integrals. If you want some more problems, I could do some more, and but yeah, pretty straightforward stuff. Not bad at all. All right, thanks.